Hello all, how's it going? Sorry I can't be with you tomorrow, or I guess now it's today for you. Um, so I wanted to take you through a lesson planning lesson sequence that I did with some NetLogo stuff. My students are working on universal gravity right now. I have the standard here for you. It says use mathematical representation of Newton's law of gravity and Coulomb's law to describe and predict the gravitational and electrostatic force. And so math representation, and I'm just focusing on Newton's law of gravitation right now. And if I go into the practice, it says, down here it says simple computational simulations are created and used based on mathematical models of basic assumptions. And so, the lesson sequence really started with a conversation about gravity and finding out what my students already knew. And we were thinking about our solar system. And I ended up taking them over to this PhET simulation first. And what I wanted them to do is collect data and think about how the data mathematically kind of determines the relationship between universal gravitational force and mass, and universal gravitational force and the distance between the masses. And so they spent some time moving these masses and then recording these forces. From there, we went to Excel, and this is an example of a graph taking the data of mass increasing and then force increasing as well. Showed that there's a direct proportionality between mass and force, and the students generated these graphs. So we knew that mass should be at the top of the equation, and then another group graphed force versus distance, and we kind of got this inversely proportional, inverse relationship. And so we kind of knew that as distance increases, force kept getting smaller and smaller. And that's when we decided to make our own universal gravitational simulation. And so that's when we went to Richard's website, STEMCCM.com, and the students hadn't been working in NetLogo yet. So I said, I wanted to get them going, especially with that performance expectation. This is the first time it's really calling for, for students to make computational simulations. So anyway, I headed over to STEMCCM, and basically spent a week in the computer lab letting the students go through these 15 modules. They just ran them online because we didn't have NetLogo downloaded on those library computers because they just got switched. But it was nice to be able to run them online. You could do that with a Chromebook too. And anyway, so the students just worked through the 15 model sequence, and it got to the point where how can we go from having students run through these models to then make a universal gravitation simulation? I knew the students were going to need some scaffolding to get there. And so that's when I showed them this energy simulation that I put together a while back. You guys have seen this one before. It's just simply, you can change the height of a block, hit setup, and go, and it tracks the kinetic energy, potential energy, and total energy versus time. But what I did, I showed them that. The kids thought this was a cool simulation. They were impressed by it because they haven't started making their own simulations, and they had just spent a week using NetLogo and modifying NetLogo, but it was time to create. So we went over, and I went through the code with them and the comments, and I posted this on Edmodo for them, and that way they had something to work off of. And then they started making simulations, and I knew I had to stress globals, and I showed them how to put equations right into NetLogo and have it spit out answers. I also showed them how these sliders work, which was really critical. And then the students started making their own simulations. Here's one of them that they made. They wanted to do a solar system version of universal gravitation. So when you hit go, they fly around really fast. I'm going to throw a weight 0.1 in here. And here we go. That's a little better. And they took the time to do some art for these planets, which is really cool. But what I was most impressed with was their ability to monitor force and to be able to change planet sizes. Oh, here we go. Here's mass A and mass B. So you can kind of take this and change it to different values and hit setup, and as you can see, the force would change. As that happens, you go into the code and you can see they've embedded the universal gravity equation right here. And this one actually is funny because this set G needs to go, you know, above the set F, and they need to put the G into the equation. So they're setting G, but it's not affecting the gravity equation yet. But that's what happens when students are coding for the first time. But anyway, I just wanted to show an example of one way that I was able to go from basically a standard to STEMCCM to actual students creating, working with NetLogo. All right, you guys have a great day. I'll miss you. I'll see you at the final SIMMS. All right, bye-bye.